ऊ मुन हेलो केटाहरू के छ म चाहिँ आज यहाँ छतमा छु छतबाट नाइट स्काई भ्लग हान्दैछु म त्यही भएर मेरो यहाँ क्यामेरामा अलिक कालो कालो आएको छ अब तपाईँहरू देख्न सक्नुहुन्छ चन्द्रमा त्यहाँ चाहिँ कस्तो राम्ररी चाहिँ टल्किएको छ अब यहाँ ताराहरू पनि म यहाँ हेरिरहेको छु तर दिनदिनै मलाई यही छतबाट नाइट स्काई अब्जर्भेसन गर्दा गर्दा मलाई यहाँ झ्याउलाइसक्यो मलाई चाहिँ कहिलेकाहीँ अमेरिकामा गएर नाइट स्काई अब्जर्भेसन गर्ने भने कस्तो तारा देखिन्थ्यो होला कहिलेकाहीँ यसो अस्ट्रेलिया पुगेर त्यो चन्द्रमालाई हेर्ने हो भने ब्राजिल पुगेर त्यो मुनलाई हेर्ने हो भने कस्तो देखिन्थ्यो होला जस्तो लाग्छ कहिलेकाहीँ चाहिँ मलाई एउटा बबालको न्युटोनियन रिफ्लेक्टर टेलिस्कोप पाउने हो भने अनि त्यसले हेर्ने हो भने कस्तो बबाल देखिन्थ्यो होला जस्तो लाग्छ कहिले चाहिँ मलाई फेरि होइन एउटा रिफ्र्याक्टर टेलिस्कोपहरूले एउटा दुईवटा तारा हेर्न जस्तो लाग्छ तर मसँग केही पनि छैन अब यस्तो बेलामा मैले के गर्छु त So yeah everybody, welcome to Simulation Squared. Simulation Squared? What is Simulation Squared? I call it Simulation Squared. You know, this is Stellarium and I call it Simulation Squared. Why, Saswat? Um, Many scientists say that we are living in a simulation. If this universe is a simulation, then the Stellarium is a simulation of the universe, which is the simulation we are living in. Simulation in the simulation. Simulation square. Hope that makes sense to you. Just let's get started. So in this video, we are going to, just navigate through the basic tools of Stellarium, and I'm going to tell you how to, use this better. So you can see it if you move your cursor, to the left end of your laptop screen or PC screen, anything that is, this thing will pop out, this bar will pop out, and you can choose this. You can see the little icon right here. That's the location window that can you can change the location. That's it. So suppose I'm in Kathmandu. Suppose I'm in Kathmandu. Let's get it. This is the sky. This is okay. Let me like turn all this off. Okay, let me turn this all off. We need that. Okay, we don't need meteor we don't need satellites. Okay, this is what it looks from Kathmandu, if you see it from Kathmandu. But just let get to the day. So for example, I can change this to Texas, and day. Good morning, Texas. This is the day, and what you see here is the horizon. You can just left click and drag it like this, and you can navigate through the directions and things like that. This is the horizon. What you call it, horizon. What you call is horizon, and this is a pretty good horizon, and you can do things with it. You can actually, remove the horizon like this. You don't need to do that. You can actually change the horizons through this configuration window. So let's say it is not actually the configuration window. I think it's this. So let's go to the landscape, and let's say you want to view it from Mars. This is the Mars. Crazy, right? And this is the Mars rover. Whoa, crazy. NASA, crazy. This is so cool. So what happens is you can actually go to Mars. So I can choose the country. I mean, sorry, the planet. I can choose to go, and let's go to Perseverance, right? Yep, this is right what you say from Mars. Good morning, Martians. If you're watching it from like another 100 years, yeah. So, but let's switch to Earth, guys. Let Elon Musk do his work. Let's switch to Earth. Let's go to. Okay, why am I doing this? Let's go to Kathmandu. Southern Asia. Good. So this is the night. This is like this is 21:23, 9:23, and this is the sky at 9:23 right from Kathmandu. Oh yeah. So you can change the date and time actually. Suppose today is 11 today is 8 November. So suppose you like to say it how you like to know how the sky will look tomorrow. Do this. Pretty easy, huh? Suppose you like to see how the sky will look just a year after. Pretty easy, huh? And this is really it's useful when it comes to, suppose the eclipse is going to happen tomorrow or a year later. You can sense this. You can literally go like, you know, 1,000 years back. Just see this. 1,000 years back. Just see this. You can literally go like this. 54,000. Oh, the horizon has been set to, Mars. We don't need that. Let's go to our own. What was that this? Anyways, whatever that was. Yeah, you can actually change anything like that, date and time, but let us keep that, you know, 2025, 11, 8, you know, we like where we are, and this is the Julian day and things. Um, you better edit this if you are like really interested in it, and many astronomers use this Julian day thing to like, do some astronomical things and calculations that not of our concern. That's not of our concern. We can actually go to this. You can like customize what you see on the screen through this sky culture. The thing about a sky culture is that this now is modern. So if I click on sky culture constellation art, this is this. Looks pretty cool. I mean, suppose suppose these are the constellations line, and Formalot, this is a Formalot, and this is a constellation. Constellation labels. This is Southern Phase. This is Capricornus, and this is Eagle. And you can go to Pegasus. Here is it, and you just. I mean, if you're pretty interested in looking at the sky, art, then give it a try. Okay, now let's go to the configuration window. If you have to configure something, you have to change the system date and time, date and things and that. We don't generally use this. If you're amateur astronomer, don't think of this. You don't need this right now. And this astronomical calculations, again, you don't need this. And help window if you need any help. Okay, let's go here. So what you have here is um we have the constellations lines. What you see here are constellations. Constellations. Crazy. Right, what you will see from this location in Kathmandu. Is it literally from Kathmandu? And you can see what this is. This is the moon. This is the moon. So when you look from Kathmandu, look at the northeast, then you will see the moon right there at this very date and time. Oh, this is Vega. Some people like to be Vega because this is crazy. Some people like to be Vega. Some people like to be Sirius. I don't know. Isn't Sirius the brightest star in the night sky? Um, Sirius is actually, what we call is dog. Let's not care that constellation labels. Um, Names of constellation. That's it. You know it. This is a dolphin. Does it seem like a dolphin to you? No, then don't care. Um, then constellation art. I will told you about this, and this is a equatorial gate, and this is like the coordinate system. And again, you can do some, you know the thing about the equatorial system is like latitudes and longitudes. For example, United States Texas has a fixed latitude and longitude, right? Any single place on earth has a fixed latitude and longitude. That doesn't sense. And for the universe there is this thing like right ascension and declination. they don't change. For example, if we click on this, okay, let's click on a star rather. Let's click on this. Suppose this is a star. I don't know what this is. This is a double star. You can get every information right here. Stellarium is really good. Um, it has fixed right ascents and then declination. You know what? Right ascents and the declination is fixed. So see this right ascents and declination. See, this doesn't change. These things are changing. Our angle is changing, and then altitude azimuth is changing. The thing is, altitude azimuth is like the based on the horizontal coordinate system, and this is upon the observer. I mean, like this changes uh from horizon to horizon. So let's just not do that. Azimuthal grid again. This is the horizontal coordinate system. This is the what do you call this, zenith. We don't need that. Ecliptic grid, you don't need that. You don't need that. I just added it here. This is the ground. So as you know already, this is the ground. This is the horizon which I'm looking from, right? So this gives a fairly good idea. Like it calculates the, the Kathmandu has a fixed altitude from the sea level, and it actually simulates that, right, that thing here. So if the moon sets and a star sets, then below the horizon you can see this Gemini thing below this, unless you remove the horizon, you can see through the earth. Oh my god, you can see through the earth. That's crazy. That's crazy. um um you know let's turn this on. And this is the atmosphere. This is atmosphere. So the thing about atmosphere is that um Earth's atmosphere, that has a certain light pollution level and things like that. So if I turn this off, then we can see more stars. See more stars right here. Crazy. There are more stars. I can see stars more clearly. Why? Because there is no atmosphere. We are assuming that Earth has no atmosphere. Then you will see the stars like this. Okay, let's turn that on again. And deep sky objects, emission nebulae, and some Messier objects, ancestries and galaxies. These are the deep sky objects. Suppose, oh, it has shown this deep sky objects. There's the open star cluster. You can navigate through that if you are really into it. Um, and these are planets. So these are planets. So if there's anywhere, if there's any planets anywhere, then it will show the name itself. Um, and then what we have is, oh my god, this is so this is a meteor source. It will show you meteor source, you know, and you can, pretty kind of know which meteor source um is there in the sky happening. That's pretty good. And artificial satellites, every single place there is like Starlink. I mean, like, anyways, these artificial satellites, we don't need that right now. And to, quickly go for what the time, you can click this. You can see Earth is rotating. Stars are rising from the east, setting to the west. You can see, and you can do it even faster. This is cool, huh? This is cool. You can just see this and spend your days. This is simulation. This is simulation. Wow, crazy. You can see all the stars, um they are changing, but you can see one thing, which is this is not changing. Why is that so? This is the Polaris. If you do not know, in case, this is the Polaris, and Polaris is called the North Star. And suppose this is the axis of Earth, this is a sphere, then why would Polaris change? Because it is directly at the north celestial pole. So even if the Earth rotates, it will be right here. So every other constellation's stars will rotate um, around the celestial pole, and just a few, approximately some distance from the celestial pole, there is the Polaris. That is why it's called Polaris, the pole star. So if I turn on the azimuth equatorial grid, you can see Polaris is very fairly near to the North Pole. That's the reason it doesn't seem to change its position. But you know Precision is slow, but it's got reasons. I hope you have listened to my music video. You'll get to know it there. Precision is slow, but it's got reasons. Some years from now, some 10,000 years from now, Polaris is not going to be a North Star. We are going to be missing you, Polaris. Um, so yeah, that's it. So let's get to the some crazy things. So let's like sort something. You know what? Let's first, you know, pause this and then let's like sort something. So yeah, Polaris already. Let's go to Andromeda Galaxy. That is the Andromeda Galaxy, if you see right there. Whoa, that's crazy, isn't that? That's crazy. That's the Andromeda Galaxy. And at night to do the very sky observation, you can use a stellarium and know where the Andromeda is. You can see it is between the north and the northeast, and you go to the top of your house or anywhere and just look at the north and the northeast between of them, and you will find the Andromeda constellation. And right here you will get our nearest neighbor, the Andromeda galaxy. So for example, if I want to um you know uh you don't have telescopes, I don't have telescopes, but if I want to know that by using a specific type of telescope which has like some aperture and some focal length, um how old the FOV be like, and how old the object you are looking look like, then you can actually simulate that right here. For that, you can do this. You can go here and then you can go to telescopes, right? So what I've done is like, let's add our own telescope. You can add your own telescope. Okay, we can go to generic 60 to focal length 700. Can we do like, you know can we do like, I mean, I don't know, just to 1200. I'm just putting random numbers, and 500, and let's add it to yours. So what happens is, if you click on this thing right here, which looks like a little eyepiece right here, you will see this. You will see this. This is the FOV, I think. This is the FOV, and the telescope, if you view it from that the very telescope which has 80 mm and f number is 5, then it will look like this. And suppose I want to change this from the 13.8 f number telescope. um, you'll view the Andromeda galaxy like this. So similarly from this the telescopes are changing. You can see here, see this from f 2.8, 2.0, and 2.8, f 1.4. These are crazy. And from 135 mm 2.8 f number, you'll see the very Orion, I mean the very Andromeda galaxy. Suppose now if you want to view the Orion, let's go there. Oh, this is below the horizon. How am I going to see that? This is horizon thing. So for that, you can just remove your ground. This is the Orion constellation, the Great Hunter, and right here is the this is the Orion constellation. Just know that this is the Orion constellation. So let's search for, I mean, the Orion Nebula, which is M42. Isn't that M42? Yeah, M42. And let's see that from our telescope. See, from this specific telescope right here, photo lens 135 mm, 2.8 f number, uh, Orion nebulae will look like that. And you can change the things. Is generic 60 times 1000. You can change how old it look like. This is crazy. This is just cool. Let me turn off the constellation things. Now let's search for, you can search for anything. I mean, you can search for M57, let's say. Let's go to M57. This is a great ring nebulae. And so let's see how my my telescope will view this like that. Where has my telescope gone? See this. From like F10 number, you'll the ring neighbor you like this will look like this from this specific telescope with these attributes, and from this specific telescope it will look like this. This is the FOV, and from this specific telescope, you can just change, and you can just add your own telescopes. You can just add your own telescope. So diameter, I'm going to be making it 500. I'm going to be making it 1000. Add, and you just delete this. I don't need that. Okay, the baby, what is number? Okay, where has that gone? No, where's that gone? 1200, and this is 500. It's set. So what happens is, um you can go to your telescope right here, and this will look like that. You just can just know how to use the stellarium, and know how to add your own telescope. So from this specific telescope, 500 mm and 80 mm, it will look like this. It will look like this. And from this specific telescope with, let's say, 500 mm, you know set is 500 mm, it'll somewhat look the other way around. you know um eh? Why hasn't that? Okay, this one, yeah. From that specific telescope, it will look like this, and you can sense any way you want. And this is the ring nebula, and many people confuse ring nebula. See how this looks like. Many people confuse this with our dumbbell nebula. Where is my dumbbell? Oh, it's not here. Anyways, this is called dumbbell. Does it look like a dumbbell, guys? But this is called dumbbell. With from this specific telescope, the dumbbell nebula will look like this. And just just let's change this. F number 2.0, lens 24 mm. It will look like this. So yeah, I think that's like some you know uh uh short guide to how to be getting started with Stellarium, and how to navigating through this, and how I think you have learned about zooming and movement. Do this. Move your cursor by clicking on the left by doing the left click, and just zoom by using your scroll wheel. Okay, that was it, guys. Hope this beginner's guide was fruitful. Meet you in another video.